Very quickly, we figured out he's dead, and it turned into a bit of this is a crime scene to some degree, CSI crime scene wildlife.
Something was killing apex predators in the Florida swamps. Not an alligator, not a panther, not anything on the list of animals researchers had spent years tracking through that flooded wilderness. Something else. Something already living in the same black water, coiled in the same decaying leaves, slipping past the same scientists who had walked those trails 100 times without a second look. In 2021, a research team tracking Burmese pythons started losing their animals. One signal after another, just gone. When they brought the X-rays back to the lab, they stood in front of the imaging screen and went completely quiet. A python spine, intact, curled inside the stomach of something else. The surgical transmitter still broadcasting, still beeping, still pulsing from inside a predator nobody had identified. 3 pythons swallowed whole, no remains. No explanation, just a signal moving through the swamp inside something that shouldn't have been capable of what the data was showing. Then the cameras got it on film, and what they captured rewrites everything researchers thought they knew about Florida's most devastating ecological crisis, and about the one predator nobody ever thought to watch, the one that had been there the entire time, doing its work in silence while the scientists looked everywhere else. The disappearing signals. Dr. Ian Bartasek and his team at the Conservancy of Southwest Florida were running what looked on paper like a quiet field study. Surgical transmitters implanted into juvenile Burmese pythons, radio tracking through the wetlands, movement corridors, hunting ranges, survival data, the kind of methodical science that ends up in spreadsheets and academic journals, not headlines. Researchers wading through chest high water, following electronic signals, doing the slow and unglamorous work of building a dataset one coordinate at a time. Then the signals started dying. The transmitters weren't failing. Every few seconds, clockwork, the pulses came through clean, steady, and reliable. The hardware was functioning exactly as designed. It was the pythons attached to them that were disappearing. Python 19 was first. 3 weeks of perfect data, movement patterns, rest cycles, activity windows, all consistent with a healthy juvenile python establishing itself in new territory. Then total stillness. Not the stillness of a cold, blooded animal slowing down on a cool night. Not a rest interval between hunting forays. The kind of stillness that only means one thing. Bartosek's team pushed through cypress roots, chest, high sawgrass, and standing water to reach the coordinates. Florida, heat pressing down on them like a physical weight, mosquitoes in clouds, visibility limited to whatever the flashlight beam could cut through the vegetation. When they arrived at the signal's location, every person on that team stopped moving. No carcass, no blood, no drag marks, no shed skin, nothing disturbed at all. Just a faint electronic pulse, steady and rhythmic, broadcasting from inside something else's body. Something had swallowed their python whole, transmitter and all, and it was still out there, still moving, still digesting. Then it happened again. October, same year. 2 more signals flatlined in the same pattern. 2 more pythons gone without a trace, without evidence, without explanation. Transmitters pulsing from coordinates where pythons used to be now broadcasting from inside unidentified stomachs. The X-rays came back from the lab. Bartosek stood in front of the imaging screen and stared at the python's spine curled inside an unknown stomach cavity. One documented case involved an animal over 50 lb, nearly 13 feet long, its neck destroyed, the body buried under brush. Something had killed this apex predator and consumed it entirely. He described it later as the most surreal moment in 20 years of field work. 3 pythons, 3 transmitters recovered from inside something unknown, something still out there hunting, operating in a swamp full of researchers and cameras, and not one person had seen it. The team ran every diagnostic available. The equipment was functioning perfectly. The data was clean, which meant only one thing. Whatever was out there was real, was large enough to constitute a 13-feet snake, and was good enough at disappearing that an experienced field crew hadn't caught a single glimpse of it. The invasion that already won. Before you can understand what the footage revealed, you have to understand why a python killer in Florida should be impossible. Burmese pythons don't belong here. They never did. They evolved in the tropical ecosystems of Southeast Asia, inside food webs built over millions of years to contain them. Myanmar, Thailand, Vietnam, Indonesia, landscapes where natural predators, competitors, and disease pressures had been refined across geological time into a balance that kept python populations in check. King cobras hunted them, tigers took them, monitor lizards raided their nests, parasites and pathogens thinned their numbers. The entire ecosystem had spent millions of years learning how to live alongside these animals without being destroyed by them. None of that came with them to America. The exotic pet trade of the 1980s and 1990s brought thousands of Burmese pythons into the United States. Baby pythons were cheap, visually striking, and manageable at 12 in. Then they grew. Owners watched their novelty animals stretch to 15th, 18th, 20 AFT and made a decision that would reshape an entire ecosystem. They carried them to canals, to wetlands, to the Everglades itself, and let them go. Living weapons released into a landscape that had no evolutionary memory of what a Burmese python was. No predator trained to hunt them, no competitor equipped to challenge them, no immune response of any kind. Then Hurricane Andrew hit in 1992, a Category 5 monster that tore through South Florida with sustained winds of 165 mph, flattening entire neighborhoods and ripping the roofs off commercial buildings across Homestead and Florida City. Among the structures destroyed were multiple commercial reptile breeding facilities that had been operating in the area, warehouses full of exotic snakes, lizards, and amphibians destined for the pet trade. The hurricane put hundreds of Burmese pythons directly into the wild in a single night. What had been a slow leak of individual pet releases became a catastrophic flood of breeding age animals released simultaneously into prime habitat. These animals arrived with zero natural predators. Nothing in the Everglades had evolved to hunt them. Nothing had learned to fear them. Nothing had even encountered them before. The prey species of the Everglades, mammals and birds that had developed their survival strategies over thousands of years in response to alligators, panthers, bobcats, and raptors, had no defensive template for a 20-fest constrictor that hunted by ambush and killed by suffocation. They didn't recognize the threat. They didn't flee from it. They simply died. The numbers that came out of the research stations over the following decades read like an extinction report. Raccoon populations in surveyed areas of the Everglades collapsed by 99.3%, not declined, collapsed. Opossum populations dropped 98.9%. Bobcats fell by 87.5%. Marsh rabbits, muskrats, cottontail rabbits functionally erased from areas they had occupied for thousands of years. Adult white-tailed deer swallowed whole. American alligators armored. Ancient, having survived the extinction of the dinosaurs, consumed in single meals. Remains of 58 different bird species pulled from python digestive systems, including migratory birds that had flown thousands of miles from Canada to winter in Florida. Gone. This didn't happen across centuries. It happened in decades. In some areas, in years. Dr. Frank Mazzotti, a wildlife ecologist at the University of Florida with over 2 decades studying this invasion, estimates the python population at tens of thousands, possibly hundreds of thousands. An invisible army, perfectly camouflaged, perfectly patient, dismantling one of America's most irreplaceable ecosystems from the inside out. The federal government responded with everything available: banned importation of Burmese pythons, classified them as injurious wildlife under the Lacey Act. Florida launched bounty programs that paid hunters for every python removed from public lands. Detection dogs were trained to locate pythons by scent, tracking the chemical signature of shed skin and waste products through miles of dense vegetation. Thermal drones deployed across the Everglades, scanning the landscape with infrared cameras designed to pick up the heat signatures of basking snakes. Competitive removal events, the most famous being the annual Florida Python Challenge, brought hunters from across the country to spend weekends wading through swamp water with machetes and snake hooks. Environmental DNA sampling tested water sources for traces of python genetic material. Acoustic monitoring stations listened for the specific vibration patterns produced by large constrictors moving through vegetation. Aerial thermal surveys covered thousands of acres from helicopters. Every tool available was thrown at the problem. Multiple agencies coordinated. The Army Corps of Engineers engaged. Millions of dollars in federal and state funding allocated across multiple budget cycles. Nothing moved the needle. Every researcher who spent serious time with this problem eventually arrived at the same conclusion. They said it in different ways, carefully in grant applications, plainly over coffee. But it was always the same admission. The pythons had won. The Everglades, as they had existed for thousands of years, were lost. Dr. Mazzotti, standing outside Naples after 3 weeks in the field, said it directly. The ecosystem is being eaten alive, and we don't have a predator that can stop it. Nobody argued. The science didn't allow for argument. The numbers were too stark, the trend lines too consistent, the habitat too vast, and too compromised for any realistic intervention to change the outcome. An ecosystem that had taken thousands of years to build was being quietly, systematically dismantled, and the best minds working on the problem had run out of answers. Then the transmitters started going dark on Bartoszyk's monitors. The answer nobody expected. Something was consuming apex predators whole, leaving no evidence, and continuing to move through the swamp as if nothing had happened. That much was certain. But every answer the research team reached turned out to be wrong. Giant alligator, logical first candidate. But the damage patterns didn't match. Alligators crush, they death roll, they leave catastrophic physical damage on anything they take. Shattered bones, torn tissue, partially consumed remains scattered across a wide area. These pythons had none of that. No wounds, no external marks. Just gone. Florida panther, panther's ambush. They bite through skull or spine with precision that leaves clear puncture wounds, claw marks, definitive evidence of a mammalian predator. There was nothing. No fur transfer, no scratches, no footprints in the surrounding mud. Black bear, powerful and opportunistic, certainly capable of killing a snake, but bears don't swallow 13 foot constrictors in a single piece. Nothing that size does that. Bears tear prey apart. They leave scattered remains. They leave scat. They leave tracks that are unmistakable in soft ground. These pythons had been consumed intact from tail to head without a single bone out of place. Whatever had done this had consumed the entire animal in one continuous process, the way a snake eats. That realization narrowed the field considerably, but it also made the mystery worse. What snake in the Everglades was large enough, aggressive enough, and physically capable of swallowing a 13 Burmese python? The answer, according to every model the team ran, was nothing. No native snake species in Florida was documented as capable of that kind of predation event. The models said it was impossible. The transmitters said it had happened 3 times. They cycled through every remaining candidate in the Everglades food chain. Hawks, owls, other large constrictors. Nothing fit the evidence. Whatever was doing this operated by a mechanism their models couldn't produce. So they did what any desperate research team does when the data refuses to match the theory. They mounted cameras across the study area, trained them on every location where a signal had gone dark, and waited. Weeks of empty footage. Sawgrass bending in the wind. Waiting birds standing motionless. The occasional raccoon crossing the frame. Hour after hour of nothing. The kind of waiting that starts to feel like defeat. Then a researcher pulled up a clip one morning and the review session stopped. Nobody in that room spoke for a long time. The predator wasn't an alligator, wasn't a panther, wasn't a bear or a raptor or anything that had appeared on their list of suspects. It wasn't even large. The camera showed a thick, dark, bodied snake, heavy and muscular, lying completely still in the leaf litter, at the water's edge, invisible against the decomposing vegetation. Not hiding, not fleeing, waiting. Positioned in a perfect ambush configuration, the kind that only an animal intimately familiar with this exact terrain could choose. It had selected a spot where the substrate color matched its dorsal pattern exactly, where fallen palmetto fronds created a natural funnel toward the water's edge, where any snake moving along the shoreline would pass within striking distance without ever seeing the threat, and then it moved. Explosive, surgical, instantaneous. The strike covered the distance between predator and prey in a fraction of a second, faster than the camera's frame rate could cleanly capture. It locked onto a juvenile python before the prey had time to register what was happening. Before the python could coil, before it could flee, before it could mount any defensive response whatsoever, a Florida cottonmouth, working slowly, methodically, unhinging its jaws around the python's tail and walking the entire body down its throat, inch by inch. A process that took over an hour, captured in its entirety on infrared camera. Patient, mechanical, unstoppable once it had begun. A Florida cottonmouth, a venomous pit viper that had lived in these exact wetlands for thousands of years. An animal every researcher on that team had stepped around on the trail without a second thought. Hunting invasive Burmese pythons, swallowing them whole. One native snake eating another snake. The overlooked species, the one that had been there the entire time winning. The X-ray imaging confirmed everything. In one documented case, the cottonmouth had consumed the python tail first, working the entire animal methodically into its stomach over an extended period. The cottonmouth measured between 34 and 42 inches. The python inside it was nearly as long. A snake consuming prey almost its own size, pushing the outer boundary of what anyone believed physically possible for this species. One biologist on the team said, "It felt like watching evolution fight back in real time. The perfect killer." In hindsight, this shouldn't have surprised anyone. The Florida cottonmouth, Achistrodon conanti, is one of the most underestimated predators in North America. Adults measure 30 to 48 inches. Rare individuals push past 6 feet. They are heavy, bodied and densely muscular, built for the exact semi-aquatic environments that Burmese pythons colonized when they invaded Florida. Flooded cypress swamps, drowned grass prairies, blackwater root systems where visibility drops to zero and every advantage belongs to the animal that knows the terrain best. This was always cottonmouth territory. The pythons moved into their living room. That famous defensive display, coiling up, dropping the jaw wide open, revealing the stark white interior of the mouth, is just the warning. The performance that earned them their name. The real weapon is invisible. cottonmouths are pit vipers. Between their eyes and nostrils sit heat, sensing pit organs that detect infrared radiation with extraordinary precision. They don't rely on sight or smell alone. They hunt in thermal signatures. Darkness is irrelevant. Camouflage is irrelevant. Even a cold-blooded python, slightly warmer than the surrounding water after basking or digesting a meal, produces enough thermal contrast to register. The pit organs detect temperature differences as small as a fraction of a degree. There is no hiding from a cottonmouth in its own territory, not in the dark, not underwater, not buried in leaf litter. If you produce heat, they know where you are. Then there's the venom, hemotoxic, refined across millions of years of evolutionary pressure to destroy tissue and blood cells from the inside. The venom contains a cocktail of enzymes, metalloproteinases, and phospholipases that break down cell membranes, disrupt coagulation, and cause systemic tissue necrosis. Untreated bites carry significant mortality rates in humans. For smaller prey, envenomation is nearly always fatal within minutes. The venom doesn't just kill, it begins digesting tissue before the prey is even consumed, breaking down muscle fibers and organ walls while the animal is still alive. By the time the cottonmouth begins the long process of unhinging its jaws and walking the prey into its throat, the internal breakdown is already well underway. The snake is not just eating, it is dissolving its meal from the inside out while swallowing it whole. Bartosek's team confirmed that cottonmouths regularly prey on the 27 different snake species as part of their normal diet, including other cottonmouths. They are ophiophagus, snake eaters by evolutionary design, by instinct, by millions of years of hardwired predatory behavior. This wasn't a new skill triggered by the python invasion. This wasn't an animal learning something novel in response to an unprecedented threat. This is what cottonmouths have always done. Burmese pythons had simply been added to an already long menu. Their strategy against large or dangerous prey is precise and calculated. Strike and release. One fast, accurate bite delivered to a vulnerable area, then immediate withdrawal. The cottonmouth retreats to a safe distance and waits. The venom does the work. There is no wrestling match, no prolonged physical confrontation. The cottonmouth doesn't need to be stronger than its prey. It just needs to be faster for 1 second. Juvenile pythons at 18 haven't yet developed the crushing muscular force of adults. They haven't built the dense body mass that makes a 20-foot python essentially invulnerable to anything in the Everglades. At the juvenile stage, they are just another snake, and cottonmouths eat snakes. 3 confirmed kills in a single study area within months. That is not coincidence. That is a pattern. Biologists now believe cottonmouths have identified juvenile pythons as high-value, low-resistance targets, and they are exploiting that vulnerability window with lethal efficiency. The coalition fighting back. Here's what nobody saw coming. The cottonmouths weren't fighting alone. Bartosek's tracking data revealed something that had gone completely undocumented until the transmitters told the story. 5 of the 90 monitored pythons in the study were killed by American alligators, one measuring just 9 feet, not a massive bull gator, but a mid-sized animal operating well within the size range that researchers had assumed was too small to take on a large constrictor. The assumption had always been that only the largest alligators, 13-footers and above, could realistically handle a full-grown python. The transmitter data proved that assumption wrong. Smaller gators were taking pythons regularly, apparently targeting them the same way they target any large prey item that enters their territory. Ambush from underwater, explosive lunge, death roll, done. These ancient survivors hadn't surrendered their territory to the invasion. They had been pushing back the entire time, quietly, continuously, completely unrecorded, not retreating, not adapting around the pythons, killing them. Then in June 2021, wildlife cameras captured something with no precedent in the scientific literature anywhere in the world. A bobcat, a native predator whose population had been decimated by the very invasion it was now confronting, attacked a python nest, not scavenging, not stumbling onto unguarded eggs. It engaged the nesting female directly, slashing with both front paws, driving her backward with pure aggression, and then methodically raided the clutch, taking eggs one at a time while keeping the mother at distance. The first photographic evidence in history of a native mammal raiding a Burmese python nest. One researcher watched the footage twice before trusting what they were seeing. The behavior was not instinctive. No bobcat ancestor had ever encountered a Burmese python. No genetic memory existed for this specific confrontation. The bobcat had assessed the situation, identified the eggs as a food source, recognized the nesting female as a threat that could be managed through aggression rather than avoided, and executed a strategy that involved simultaneous offense and defense. Attack the mother, drive her back, take the eggs, repeat until the clutch is depleted. These cats weren't retreating from the invasion. They weren't adapting to coexist with it. They were learning to dismantle it from the inside, developing entirely new predatory behaviors within a single generation, within a single lifetime, in direct response to a threat that hadn't existed in their territory 30 years before. The speed of that behavioral adaptation stunned the researchers who documented it. Evolution typically works across thousands of generations. This was happening in one. One ecologist who reviewed the footage said simply, "The bobcats figured it out before we did." And it went further still. Cameras covering flooded areas documented owls and hawks pulling juvenile pythons from exposed positions at dusk and first light, removing animals before they could grow into the 20 predators that swallowed deer whole. Black bears and Florida panthers were separately documented taking pythons at multiple points throughout the study area. An entire coalition, pit vipers in the leaf litter, raptors in the canopy, bobcats at the nest, alligators in the water, bears in the brush, panthers in the hammocks, all operating independently, all converging on the same target, none of them coordinated, none of them directed, all of them doing what evolution had spent millions of years preparing them to do, defending territory from a competitor that didn't belong there. The brutal math. But here is the brutal truth. It is not enough. Not yet. A single female Burmese python produces 12 to 36 eggs per clutch, sometimes more. She coils around the nest through the full incubation period, 60 to 70 days, shivering her muscles in rhythmic contractions to generate metabolic heat, maintaining the eggs at a constant temperature in a cold-blooded animal's version of brooding. She doesn't eat during this period. She doesn't leave. She defends the clutch against anything that approaches with the full force of a constrictor that can exceed 200 lb. These animals mature quickly, reaching breeding size within 3 to 4 years. They grow fast, adding feet of length annually in nutrient-rich environments. They live for 2 decades or more, and each generation produces dozens of offspring that will themselves be breeding within a few years. The reproductive math is merciless, and it does not favor the defenders. For every juvenile python a cottonmouth takes, for every clutch a bobcat raids, for every python an alligator kills, dozens more are hatching in nests scattered across a landscape so vast that no survey team can cover more than a fraction of it in any given season. Since Florida's removal program began, human hunters have taken more than 5,000 pythons from the wild. The 2024 Python Challenge eliminated nearly 200 animals in a single competitive weekend. That sounds significant. Then you hear Dr. Mazzotti's assessment, delivered without softening, barely scratching the surface. Nobody who has studied this invasion at depth disagrees. Pythons are masters of concealment that borders on the supernatural. Researchers have walked within feet of coiled, fully alert animals and seen nothing. The pythons compress against the ground, flatten their profiles, and become indistinguishable from the root systems and leaf litter that surround them. They slip beneath water for extended periods. They compress into spaces no search team would think to check. Vast stretches of their habitat remain unreachable on foot, by boat, or by any vehicle designed for human transportation. No removal effort, no camera grid, no drone sweep can cover all of it. But every action still matters. Every cottonmouth strike, every bobcat raid, every alligator kill, every transmitter recovered from inside an unidentified stomach, each one is a data point, a pixel in a picture, only now beginning to form. Each one buys the Everglades a little more time. Time for native predators to refine new behaviors and pass them forward through generations. Time for researchers to develop better tools. Time for the ecosystem to remember at the deepest biological level how to defend itself. The question nobody can answer yet. Here's what keeps the scientists awake at night. Cottonmouths didn't wait for authorization. They just started hunting. Bobcats didn't consult a recovery plan. They attacked. Alligators kept being alligators. The native ecosystem is adapting on its own terms, quietly, violently, without asking permission. While researchers were designing removal programs and applying for grants and coordinating between agencies, the swamp was already fighting back. The cameras proved it. The question the data cannot yet answer is whether it's happening fast enough, whether the cottonmouth that learned to strike a juvenile python can pass that behavior through enough generations to bend the population curve downward. Whether the bobcat raiding a nest this year teaches something through observation, through offspring watching their mother work, that shifts the dynamic 10 years from now. Whether all of it together, the vipers striking in the leaf litter, the raptors pulling juveniles from exposed branches, the gators ambushing from the shallows, the bears taking opportunistic kills in the brush, the bobcats raiding nests with learned aggression, the human hunters with their bounties and their removal events adds up to something the reproductive math of a Burmese python cannot absorb and overcome. That's the question nobody can answer yet, and it's the question that sends researchers like Bartosek back into the water every morning, chest deep in sawgrass, following electronic signals through the heat. The study is still running. The cameras are still recording. Conservancies of southwest Florida is expanding the transmitter network, building a deeper record of predation events, watching for the signal somewhere in the data that the native ecosystem is closing the gap. Bartosek checks those monitors now with a different kind of attention, not the clinical detachment of a researcher tracking data points, something closer to the focused vigilance of a person watching a war unfold in real time, not just tracking pythons, tracking the things that have been quietly hunting them all along. Every camera clip is another pixel in a picture nobody has fully seen yet. Every flatline signal is a question. What got this one? Every recovered transmitter pulled from inside a cottonmouth stomach or found beside alligator tracks in the mud is another piece of evidence that the Everglades haven't given up. Somewhere in the Everglades tonight, in the black water of Picayune Strand between the cypress roots in the dark, a cottonmouth is digesting a python whole. Its transmitter still beeping, still broadcasting, still pulsing out a signal that says something is here. Something is hunting. Less than a mile away, 100 eggs are hatching. This war is just getting started, and the next discovery could change everything.